Hi everybody, today we are going to learn how to do the communication of Modbus TCP inside PLCnext Engineering. So this is Fatima Sadhana, Technical Associate, IIPD Dubai. So let's see how these kind of communications can be done inside PLCnext Engineering. So when it comes to Modbus, you have two kinds of communication inside the Modbus, that is TCP IP communication and you have 485 communication. When it comes to TCP IP communication, it is over Ethernet. 485 communication is a serial communication in which you should have a wire, a connection through the wire, which is connected from a module inside the PLCnext to the next device. Okay. So let me open the PLCnext software. So if you want to do an extra communication, for example like Modbus TCP or HMI or anything, whatever you want, you have to add the library inside the PLCnext Engineering software. So this entire software is entirely for doing the PLC. So whatever extra you want, you have to create the library. Okay, download that particular file and add the user library, these files in the user library. So my hardware is AXCF2152 version 2023.6.0. Once that is done, now the hardware is configured. I need to go and check the IP addresses. So we can see the start addresses and end IP addresses in the one network. I'll go and check the IP address of the device. That is also in one network, 192.168.1.10. Once that is done, we have to go to the online controllers, select the Ethernet connection, Intel Ethernet, scan the device. So when you scan the device, the device will be detected in the network and will be added in the station online. So here we need to check the IP address of the station project and the station online, both are same or not. If that is not same, there is an icon here in order to make it same. So you can apply the project device setting to the online device and you can apply the online device setting to the project device also. Both way you can do it. So now we move for the IP address 192.168.1.10. Once that is done, you have to read the additional modules if you want. If you are doing something with the additional modules, you can read the actual line F additional modules. So for this you have to give the username and password. Password will be printed on the hardware itself. So I have already given the password. Press OK. You can see all the modules are displayed here. One slot is free, third slot is free in that, but if the free slot also, you have to add the module AXC, AXL, SE, SC. So that is the free slot. So rest of the modules you can see 16 digital outputs, 16 digital inputs and 4 analog inputs. Okay, so now the module is in online format. Disconnect it. Let's go to the programming part. So here you can see a program called main, which is already configured the moment you configure the hardware. Double click on this and select which programming language you are going to use. So for this communication I am going to use FBD. So I'll select ladder FBD worksheet. Once that is done, go to this PLCnext. Make sure that this particular program type is added inside the task and event. So that is also already added. Let's go back. Now we need to download the library for Modbus TCP. So let's see how we can download the Modbus TCP library. So in order to download the Modbus TCP library, we have to go to the PLCnext store website. So now I'll type PLCnext store, from where you will get all these kind of libraries. So here you can see a lot of files. So here you can search Modbus TCP. So when you search Modbus TCP, here you can see different kinds of files. Modbus RTU is there, Modbus TCP is there, TCP master, web server for web visit RM, lot of files will be there. So we'll go for this Modbus TCP. So that itself we can see a lot of versions. So the latest one is 15, 14, 13, etc. Again in 13 you can see 2 versions, 12 you can see 2 versions, just like that it will go. So what you have to do is check your version. So our software is 2023. You can go for this 0409 2023. Once you select the version, you can download the file. So here you can see the hardwares that supports this particular version. Controller AXCF2152 24042617 is device, our hardware. Then you can see AXCF3152, AXCF1152 with all these serial numbers or passwords will support. Serial numbers will support this version. Okay, so our device is 2404267. So this file will support. This will be supported by the PLC. So once that is done, you can go for this download. Download it. So here you can see the file is downloaded. So once that is done, you have to just go and extract the files. So the file is extracted. When you double click on that, you can see documents, which gives an idea about this Modbus TCP_13. See all the instructions, all the details related to that. So for example, if you are using MB_TCP_client instruction, you can see the explanation. So this explanation you can observe from the device also. When you go to the help option inside the PLCnext engineering software, for that particular instructions we can see that also. Yeah. So now we'll go to the files. So here you can see Modbus TCP_13. You can see some examples also. Okay. So once that is done, let's come out from here, go to the PLCnext software. We have to add the library. So right click on this library. There is 2 options, add user library and add library. We have to go for add user library. Go to the files. So we'll move on to the downloads. Go to files. You can see the device. Open it. So your library is added. Once the library is added, go to the programming. So there you can see the libraries, the instructions related to this particular Modbus will be displayed here. That means the very moment you add the library, all the instructions related to that also will be added to the programming. Let's expand that. You can see a data type Modbus TCP, and inside function and function blocks you can see 12 instructions. Okay, so MB_TCP_client_9, diagnostics information _enable_2. Then you can see a lot of functional blocks which has to be connected with respect to the client instruction. So this client instruction will be your main instruction, and as per your requirement you have to choose the functions inside the you can see here functions 3, function 2, function 4, function 5, etc. As per our requirement or application you have to choose that. So if you are using a server, for example this PLCnext Engineering is acting as a server, in that case you go for this TCP_server_9 instruction. Okay. So now all these kind of things are done. So first we will drag this MB_TCP_client and place it here. It's a functional block. So in this, all the variables, you don't have to define all the variables. Some of the variables will take the default values, but we'll see all the main points and add the required inputs and outputs. Okay. So first one is activate option. So activate option means you need to activate this particular instruction. So when you activate the instruction, you need a continuous supply. Okay. So that what you can do is you can directly create a tag here. So I'll give the name of the tag as activate. It's a boolean. Right click, create new variable, local. If you want to connect it to an external switch, you can do it in that way. If you want to activate it from the device itself, you can go for the local. Okay. So I have assigned this as a local. Go to the variables. So when you check the variables, here you can see the activate, boolean, local. So initially my activate should be on. The very moment I download, the true signal should be sent to the instruction. That means it should be enabled in the beginning itself. So I can assign true as the initial action that has to be given to the activate. Okay. So let's see, when I press F1, so whatever details you want related to this instructions can be observed in the help instruction. So you press F1, you can see an explanation of all the blocks will be displayed here. So double click on this TCP client. So here you can see X activate means that when it is rising edge, it activates the functional block. When it is false, it deactivates the functional block. So second one is X acknowledged, rising edge, Modbus timeouts and IP errors are acknowledged, function block is not reinitialized. So if you want to acknowledge the IP errors or Modbus timeouts, you have to assign a switch there or a memory variable of data type boolean. Then after that you have to acknowledge it. Okay. So now again third one is X auto acknowledge, auto acknowledgement and IP errors of Modbus timeout. It can be true. True means the error is acknowledged automatically. So what we can do is we can give directly the true action there. So I'll type true there. So that is done. Okay. Next one is, let's check what is that server IP. It is IP address of the Modbus server. So now what I am going to do is I am going to communicate from this PLCnext Engineering to Schneider. So this is the client. So my PLCnext Engineering is the client, or Phoenix PLC is the client, and Schneider is my server. So I have to give the IP address of the server. So I am going to read some values of the Schneider. Okay. So this has to be given in some format. Let's see what is the format. So I have to give in quotes, single quotes, that too in single quotes, 192.168.1.6. Finish the code. Yeah. So you can see if any format is changed or something has changed inside that one, it will show red color. So this is in string format. If you are giving a value and then assigning the IP address, make sure that you are creating that data type in string format. So next one is iPort. So when you do Modbus TCP, the default address will be always, or the port address will be always 502. Okay. So even if you are not assigning that 502, it will automatically take 502 as the default port address. So what next? Next one is server bind IP, directly connected to the TLC socket.bind IP, defines the local IP address of the Ethernet adapter to which the created socket is bound. So if you want to give, if the string is empty or contains value 00 or the input is not connected, a suitable Ethernet adapter will be selected for that. So as of now we don't have to select anything here. So let's see what is next one. Okay, this also we don't need to connect it. A selected port number is used by the TCP server for incoming data. If the value is 0 or input is not connected, stack assigns a temporary port. So this all will be assigned by itself. If we are not assigning, it will not create a problem. Next one is xudp_mode. So if it is false, it will act as a Modbus TCP. If it is true, the communication will change to UDP. So we need a Modbus TCP, so in that case we have to change this to false. Next one is T reconnect delay, the delay between two IP connect executions needed by the PLC. So default value is 500 milliseconds. So that also we can give. So it can be T hash 500 ms. Then timeout, time for communication monitoring. The Modbus server must respond to a request within time specified here. Otherwise, the error will be triggered. If No value specified here. The block operates with a timeout of 2 seconds. So some things you can get the default values from here, or if you have a specific requirement, or you need to be like this or in a specific way, in that case you can change the values and do it. Okay. So this is the timeout for communication monitoring, which will be in default value will be 2 seconds. You can give this as T#2S. So now you can see an option called UDT TCP _ communication data. So let's see what it is. First I'll assign a name here, a tag name. So let this be MB _ data. So once you define that, you can see on the other side also, right side also, the data, same tag name will be displayed. So I'll create the new variable. I'll make it as local. So let's go and check the data type. You can see the very moment I changed that to local, created the tag name. The data type is MB _ TCP _ UDT _ communication. So this is the tag name or the tag which connects the block with the function block. So here you can see the communication structure of the block family. The blocks are connected with each other using this structure. So now I want to connect this client to the function. Okay. So in that way you will be setting the address, all these kind of things. So I want to connect this block to that block. In that case I will be using this MB _ data. So this is used to connect between blocks. Okay. So once that is done, you can see the required data are connected. So on the other side you can see X-active, XError, diagnostic code, add diagnostic code, UDT diagnostic code, etc. So one by one let's see. X-active is if the function block is not active. Function block is active, it will show as true. Not active means it will show as false. Okay. So now X-ready means if the display is true, it shows that it is ready, and if you connect that to the next device, the signal will be, once it is ready, it will send to the function block there. So now we have diagnostics codes, additional diagnostics code, etc. So what you have to do is, if the error is true there in the XError area, if there some error is there, it will show as true. So in that case it will display, this diagnostic code will display some kind of codes there. So this explanation you can see what is the description of how you can troubleshoot the error. So 16 0000 functional block is deactivated, 8000, 8100. So these kind of diagnostics codes you can see there. So with that we can troubleshoot the device. So once this is done, I'll place MB TCP function FC3 _3. So now what we are going to do is we are going to read the values from Schneider PLC. So read the values from the Schneider PLC means I'm going to read the analog value of the Schneider PLC. So this is like you are reading the holding registers. So in that case we have to know like which function block I have to use. So that is clearly written in the explanation of this function block. So let's check that one. So here you can see Modbus TCP _ function 3. This function block reads holding registers from the Modbus server. So if I take function 1, so it will show this function block reads coils from the Modbus server. FC2 is it will read digital inputs from Modbus server. So function block FC3 is it will read holding registers from a Modbus server. Then functional 4 is reads digital registers from a Modbus server. So just like that, each and every functional block is assigned for a function. So our block is MB _ TCP _ FC3. So that's why we place that particular function block. So once this is done, we have to connect this X-ready in order to connect to the X-activate of your function block. So once this is ready, the true signal will be sent to the function 3. So now let's one by one give the values for TCP. So first thing what you have to give is, so let's check the details of the inputs and outputs. So I'll go to F1. So here you can see FC3. So AXCF2152 as usual, it's a rising edge. So that AXCF2152 we have given using our X ready of the TCP client block. So next one is X acknowledged rising edge. The Modbus timeouts and IP errors are acknowledged. So this will not initialize the block, but you can acknowledge the errors. The third one is you can see ID. So value in the range from 1 to 10 represents the connection between the blocks and may only be assigned once per MB underscore TCP underscore client. This parameter should be static. So this is the first block that is connected to your client instruction. So this ID will be 1. Next one is update time. So let's check what is update time. Waiting time in milliseconds between two read and write tasks. Okay. So if you have read and write tasks simultaneously, this is the waiting time between two read and write tasks. So that's we don't have to give for now. Next one is unit identifier. So if you are not giving, it will take a default value. So we don't have to worry about that one. So unit identifier is parameter for addressing a Modbus RTU device which is connected through a gateway. So this also I'm not giving any value. Next one is the start register. So start register means the address that we have to read. So when it comes to the Schneider, the address, what program I am going to do is I am going to read the value of the analog that I will store in an address called MW0. So that address, let me show you that one. Okay, let me open the Schneider PLC. The software is EcoStruxure Machine Expert. So now you can see 3 windows: properties, configuration, programming, display and commissioning. So here initially I have to give this as inactive just because I'm not going to give password. Apply it, go to the configuration. So my hardware here is TM221CE24R. Select that and drag it, place it on the top of the CPU. Once that is done, we have to give the IP address. So double click on the port. You can see IP addresses will be displayed here. Option to give IP address will be displayed here. So here I'll give the IP address as 192.168.1.6. Hope you remember the same address I have given inside the client block. So here you can see 192.168.1.6. This is the server IP address that is given inside the client block. So once that is done, I have to enable all the security parameters. So this is acting as my Modbus server. So the advantage of Schneider is that it is having inbuilt Modbus server inside the so you have to just go and enable it, and then you can read the values. So here you can see Modbus server enabled. Apply. Go to the programming. So here you have to select the switch. So this I'll give a memory address as M0. So this will be %MW0 equal to %IW0.0. So once this is done, select the device and login. Download it. Start controller. So when I turn on this, you can see the value moved to MW0. So we need to find the Modbus address corresponding to this MW0. So each and every devices, if the PLC or VFD, whatever it is, what kind of communication you are doing, if it is Modbus, it will have its own Modbus addresses. So we need to find out what is the corresponding Modbus address of MW0 in PLCnext. So go offline. Yeah, so let this be here. So if it is MW0, the corresponding address will be word, just because it is word, hash 16 hash 0. So if it was MW1, the address will change to word hash 16 hash 1. So that is the addressing format given to the memory addresses inside the Schneider. Okay. So you have to be very careful. This is the addressing format you are giving inside a PLCnext corresponding to the Schneider's address. So this can change when you take a different device. If you are going for Siemens, it will be entirely different way of address you will be using there. So that has to be very careful. So here you have used 16 hash 0. You can see it is 16 hash 0. So when it comes to Siemens, it will be like one value higher than the address. If it is MW0, the address will be 40,001. So that kind of changes will be there when it comes to the communication. So this you have to be very careful. Okay, so once that is done, we have to go to this quantity of registers. How many number of registers you are going to read, or how many number of values you are going to read. So I am going to read only one value. So you can see the display as unsigned integer, UINT. So the format will be, just check if I give 1, what will happen? It will not take. It is showing as red color. So the format is UINT hash 1. This is the format to give the value. So once that is done, you can see an option called UDT TCP COM data, which connects the blocks. So the same thing. So now we are connecting from this block to this block. So I have to give the same data name or tag name which I have assigned for this TCP client block inside the function also. So I'll come here and give MB_data. So you can see that will be assigned on both sides. So now I need the output. I want to see the output here. So that can be observed in this register value. Okay. So rest of the things we will see. Okay, let's watch rest of the things and then we'll move on to the other one. So coming to the output parameters, here you can see X active. So X active becomes true when the function block is active. Okay, it becomes false when the function block is not active. X NDR, true for 1 cycle. So that means if it is true, means a new data has been received. UI byte count, the number of bytes received. Register value, the value read from the registers. So you can see the data type as NP_TCP_array_W_1_125. So you have to create a a tag name with this particular data type. Okay. So the word array with the limits 1 to 125. It's not just because you have you are reading only one value doesn't mean that you can assign a tag name with integer data type. No, this is a default format that has to be given to the array register value with this particular data type. It's array of values. So let me take that one. Let me assign a variable here. I'll give this as out. Create new variable. Go to local. Let's check inside the variables. So here you can see out MB_TCP_array. Automatically this particular data type is was formed there. Just because you are creating the tag name at that terminal itself, it will create the correct data type. Okay. Next is error. So I have told you if error is true, you can see codes here, diagnostics code, additional diagnostics codes, etc. So these codes, each and every code will have a meaning. So you can see 16 hash 00008000 C010 C030 etc. So you can see the description of each and every code on the other side. So this is how it is working. So once this is done, I have to make a little bit changes in the reconnect delay. So I need to change, I can change it from here. can give the seconds as 0.3 seconds. Now again this t hash 2 seconds. So t hash 2 seconds, I'll change it to 1 second. The response between. Okay. So once this is done, I'll download the program. Make sure we have already assigned, saw the object inside the Intel Ethernet connection, online controller. So everything is done. Come to the program back. Right click, go to right and start project with sources. So I'll save the project. So this is Modbus TCP. Yeah, there is 0 error and 0 warnings. Project is downloaded. Now we have to go to the online mode. So when you go to the online mode, you cannot see anything here. So this is an array. You want to see one value. So in that case, we'll check how we can do it. So let's check rest of the things. Activate is true. Auto acknowledge is true. You can see the IP address, rest all the things. XReady is true, that is directly connected to XActivate, and all the addresses values. So XNDR means it is receiving values. XActive is true. So here you can see the error is false. So let's take this value from the array. So what I will do is, this is a different kind of structure, different kind of data type. I'll convert this into integer. So in the instructions, you have an option called conversion. You will go for that. So data type conversion option is there. So I want to convert to integer. So I'll take that, place it here. I'll take the first value of the out. So that means first value of this is an array. I need the first value of the array. So that is 1. I'll give this as value. So it's not defined. So what I'll do is I'll right click and create a local. I'll go and check whether this is integer or not. Yeah, this is integer. Once that is done, we can download the program. So here you can see 643. Okay. So I'll change the value. You can see the value is changing. Okay. So I have changed the value. You might have observed it. So now the value is 544. So this is how you read the value inside the TCP client using the TCP client block. So let's check here also. Here you can see the value is 544. Okay. So hope you understood how the communication is done using the TCP client block, how you can communicate to another device, what all configurations you have to set inside this, all these kind of things. So when it comes to Modbus TCP, you are communicating over Ethernet. IP address is the main the communication parameter that has to be set, or you don't have any other than the network, you don't have any other kind of communications required or any devices required for this one. Okay, so make sure the servers which you connect should have an inbuilt Modbus server, or you should have an instruction that can configure this kind of things. So when it comes to Schneider is having inbuilt Modbus server option. So when you enable it, it will allow the client to take the values from the server. Okay, so hope you understood it. We'll be back with another video.